Hi everyone. I just want to make a quick video on example 6. And example 6 is similar to a bunch of the examples and they all run the same principle. So I'm going to show you how to do this. I'm going to show you two ways. One way is faster than the other, but you need to know how to do the first way to do the second way. So this is a standard type of question where you're going to get some information. You always have some piece of information, but you're missing others. So it's kind of like a big puzzle. So in this question, you got the free body diagram already drawn. It's given to you. If not, you have to draw the free body diagram. I've given you normal force and I've given you the applied force. And we do know, I'm going to fill this in quickly before we get anywhere. We know if we know the normal force, we also know the force of friction, or the force of gravity, right? So those two values are equal. And they're always equal in these questions because there can't be an extra force up or down, or if it was, you have an acceleration in that direction. So if the normal force were greater, this thing would float. Doesn't make sense. So the question says, what is the coefficient of friction? Remember, coefficient of friction is that mu symbol. Based on the free body diagram provided, the acceleration is negative 2.5 meters per second squared. So these are the formulas we need. These four here formulas. Just get this highlighted here. So these formulas on the side, along with your F net equation, equals the force in the positive direction minus force in the negative direction. They're going to be what you need to piece this all together. So I like to just go in the order that I'm looking for stuff. So I need the coefficient of friction. Oh, sorry. Coefficient of friction is right here. So force of friction equals the coefficient of friction times the normal force. I have the normal force, but I don't have the force of friction. So there's another way to find the force of friction. So the force of friction would come out of your F net equation. F net is equal to all the force in the positive direction minus the force in the negative direction. I have FA, I don't have F net, I don't have FF yet. So go one more step. I need to find F net. F net is equal to mass times acceleration. I have the acceleration, I don't have the mass. Go one more step. There's our fourth formula. Fg equals mg. I know what Fg is. It's 441, remember, because these two are equal. So Fg equals 441. So I'm just going to quickly move that, and you guys can check the math. 441 equals mass times 9.8. I've got the mass. Now that I've got the mass, I've got the acceleration of the mass, I can find the F net, right? The F net is equal to Fa minus Ff, so I have those values. I got the Ff value, 262.5. Put that in here. Work backwards, find the coefficient of friction. Of course, you'd write a statement. I'm not going to write a statement right now because I just want to go through the video without taking too much of your time. So it's these steps. Is this order all the time? No, it depends on what information you have. But it's these four formulas always that tie together. Now, is there a quicker way to do this? Well, yes. If in each scenario, oh, shoot. Sorry about that. If in this scenario, if I always start with the F net equation, F net equals Fa minus Ff for this. We know that F net also equals Ma, so I'm going to replace F net equals Ma right here. I'm going to take out the F net, I'm going to replace it with Fa. Or Ma, sorry. Fa never changes, and Ff equals mu Fn. So I'm making a substitution. The Ma goes in here, and the mu Fn goes in here. So I've replaced them. I can go one step further and go Ma equals Fa, and I know Fn equals Fg, which also equals Mg. So I'm replacing mu Fn with mu Mg. Now it's a matter of just plugging the numbers in. I'm going to move my thing here so I can move my screen a little bit. Now it's just a matter of plugging the numbers in. The 45 times negative 2.5 is negative 112.5, same as above. 150, and I've got mu times 441. Rearrange, and I get the same answer. This method right here will work for all of these questions. It's substitution, but you need to show at least, I'm going to erase this right here, you need to show me, you always need to start off with this first equation. Based on the free body diagram, show you can skip the second one because it's the same as this one, except I've changed mg. So I make my substitution, plug my numbers in, find the coefficient of friction. This will work for all of your equations. If you don't like that and you like to put it together in pieces, then you can definitely go through all the steps. These are all the pieces together, right? You can piece it together or you can go to the one thing altogether. This is the key. This is the substitution method. This will save you a lot of time. Hope this makes sense. I've got another video that's similar to this one that's not in your notes. It's a YouTube video that I made last year. I'm going to link that in our assignments. And then there's another one that has a situation where there's no applied force. So check those videos out. If you have any questions, send me an email or post something on Teams and we'll look at it. If you get stumped on anything, same thing, contact me. And when we figure out when our tutorials are going to be, I'm still waiting for some surveys, but those of you that sent them in, thank you. And then we will pick some time so we can have a kind of a tutorial time if anybody needs some help. All right, thanks. Good luck.